Hello my dear students. Today we are going to discuss about most important topic of the chapter, some basic concept of chemistry, that is limiting reagent. So we'll be discussing what is limiting reagent and we'll be solving few questions related to the limiting reagent. After solving these questions, it's going to be very easy for you to understand the questions related to limiting reagent as well as to solve the questions very easily. So we'll be starting. What is limiting reagent? We'll see the definition. What is that? The reactant that get exhausted first and limit or stop the reaction is called limiting reagent. So limiting reagent is that reagent that get exhausted first. So if it got exhausted, then it is gonna stop or limit the reaction or the amount of product formed. So the one which limits the amount of product formed is what we are calling as limiting reagent. Obviously, if a reaction happens, you will have two reactants. Let's say A and B is reacting to give you C. So if B is that limiting reagent which is getting exhausted first, then obviously A is going to be the excess reagent. The reagent or reactant that is left at the end of a reaction is called excess reagent. So at the end of the reaction, if something is left, we'll call it as excess. And if the reactant is fully consumed in a particular reaction, then that reactant is what we are calling it as limiting reagent. Fine. So how we are going to find out the limiting reagent? So we have to use this formula. This is a basic and very interesting tricky formula. By using this formula, you can find out which one among these reactants are limiting reagent. So look at the formula. Checking LR. LR is nothing but the limiting reagent. Given value by stoichiometric coefficient. Whatever the value they have given by stoichiometric coefficient. You have to do this one first. Look at that. This value may be moles or volume or molecules. That is given value in Solumbodha. This value can be, we can divide moles by stoichiometric coefficient. We can do volume by stoichiometric coefficient. We can have molecules by stoichiometric coefficient. But not mass by stoichiometric coefficient. This cannot be done. Listen carefully. Given value means it should be moles, it should be molecules, it should be volume, not mass. If mass is given, you have to convert that into moles and you have to do that. Sir, why we are finding out this? Yes, there is a reason. If you got the values, let's say you got different reactants, as I said, A and B, giving you C. I am gonna find out the n by stoichiometric coefficient or given value by stoichiometric coefficient of A and given value by stoichiometric coefficient of B. And if the value is lower for A, let's say if I found out the small by stoichiometric coefficient value, for A it came out as 5, for B it came out of for B it came out of as 10. Now for A it is 5, for B it is 10. Which value is lesser? 5 is the lesser. That means A is the limiting reagent. So you have to find out the value by stoichiometric coefficient. Which value is lesser one? That one is the limiting reagent. So least value, which value? This one. Generally we'll take moles. So I am writing this number of moles by stoichiometric coefficient. So number of moles of by stoichiometric coefficient value is least, then that is what your limiting reagent. That's it. So you should remember only one thing. What you have to remember? You have to remember the equation for limiting reagent. So that equation is given value by stoichiometric coefficient. If the value is least, then you got your limiting reagent. That is how you identify the limiting reagent. So again, I'll be making it clear for you. A plus B give you C, and here let's say A plus 2B give you C. And number of moles of A they have given us 10, and number of moles of B they have given us 30. Fine. Now I wanted to find out which one is the limiting reagent. So just remember one thing. In order to find out the limiting reagent, first you have to understand whether this question is a limiting reagent question or not. How will you be identifying that? In the question part, whether this question is a limiting reagent question or not, how you will be identifying? In the question, if they will be giving you two reactants value, If they are giving the values of two reactant, obviously that's going to be limiting reagent question. If only they have mentioned about the values of the moles or mass, whatever it is, if they have mentioned only about one particular reagent, then obviously you will not be having any limiting reagent. If they have given the values of two reactants, there's a high chance that you will have a limiting reagent. Now they have given you number of moles of A and number of moles of B. Then you will be having a limiting reagent possibility. We'll find it out. Stoichiometric coefficient here is 1, here is 2. And number of moles, we can say A is 10, B is 30. So I'm going to find out the number of moles by stoichiometric coefficient value. Number of moles is 10, stoichiometric coefficient is 1 for A, number of moles is 30 and stoichiometric coefficient is 2. So what is the value? Here it is coming as 10, here it is coming as 30 by 250. Which value is less? 10 is less. So which is going to be the limiting reagent? A is going to be the limiting reagent. If A is the limiting reagent, then what you have to do? You have to relate all the other reactant as well as the product with limiting reagent. That means in the general equation, as we have seen in our previous lecture, I'll be giving that in the description so you can see that link. So in that I am applying the mole concept effectively into the equations. If you apply the mole concept in the equation, I can write as this is Na by stoichiometric coefficient of A is equal to Nb by stoichiometric coefficient of B, which is equal to Nc by stoichiometric coefficient of C. And that part we have randomly taken 2 and we have equated. This case we got A as a limiting reagent. Now you have to, if you wanted to find out B, you have to equate it with A. If you wanted to find out C, you cannot equate that C with B. What do you have to do? You have to equate that with A. So whatever you do, first you have to find out the limiting reagent. Then if you wanted to find out product or the other reactant, you have to find it with respect to the limiting reagent. That is how it works. We'll find that in a few examples. Now look at the question. This is what the question. We'll find out the number of moles of C produced. They have given a reaction. We are writing the reaction. 2A plus 3B gives you 4C plus 5B. Fine. First I am going to write stoichiometric coefficient. Here 2, here 3, here 4, here 5. Then number of moles I am going to write. A is 10, B is 50 and product we don't have any idea. We wanted to find out the number of moles of C, but we don't know that. But they have given the values of two reactants. If they have given the values of two reactants, I have already told you what you have to find. You have to find out the limiting reagent. How will we be finding out? N by stoichiometric coefficient. So 10 by 2 here, 50 by 3 here. 10 by 2 is 5. 50 by 3 is going to be 1, 2, as 16 point something, right? So whatever it is, 16 point something will come, and what do you need? You need the lowest value. So which one will have the lowest value? A is having the lowest value. So you got the limiting reagent. A is what your limiting reagent is. Now you have to equate A with C. You wanted to find out C, right? Yes, if you wanted to find out C, you have to find out the limiting reagent because they have given two reactants. They have given the values of two reactants. From that, we have successfully found out the limiting reagent. Now you have to apply mole concept into this limiting reagent as well as the one we needed. So how will we be applying that? Number of moles by stoichiometric coefficient of A is equal to number of moles by stoichiometric coefficient of C. Number of moles by stoichiometric coefficient of A we have found out already as 5. The number of moles of C by stoichiometric coefficient. Stoichiometric coefficient is 4. So number of moles of C I got how much? 5 into 4. That is it. I got the answer only. The game is over. That is what you have to do. Clear? I hope you got clarity with this. We'll go with another question. Fine. They have given a reaction. Fine. First we'll be writing that reaction here. A plus 5B gives you C plus 3D. In this reaction, identify the limiting reagent. Yes, we have to find out the limiting reagent. If the reaction starts with 10 moles of A and 10 moles of B. Again, they have given the values of A and B. Obviously, you will be having limiting reagent, and they are asking us just to find out the limiting reagent. So stoichiometric coefficient will write 1, 5, that is it. We don't have to mention here because we need only the reactant. We have to find out the limiting reagent. Number of moles. Number of moles of A is 10. Number of moles of B is 10. Very good. So number of moles with stoichiometric coefficient. Here 10 by 1. Here 10 by 5. So 10 by 1 is 10. 10 by 5 is 2. Am I writing it correct? Right? 10 moles of A, 10 moles of A, 10 moles of B, 10 moles of B. So chemical coefficient is also good. 10 by 1, 10 by 5. So what you are gonna get? Which is the limiting reagent? Yes, B is the limiting reagent because number of moles by stoichiometric coefficient is least for B. That's it, how simple it is. So this is how we have to solve. Now look at this question. Okay, 4 gram of hydrogen is reacting with 32 gram of oxygen and they are exploding, you will be getting water. And in this particular question, what they are asking, what is the volume of water vapor formed? What is the volume of water vapor formed at STP? They are asking the volume of water vapor formed. Can we do it by the same method? Yes, of course we can do. At STP, just remember, STP, what is the molar volume? This is 22.4 liters, right? Volume occupied by 1 mole of a gas at STP. Here the pressure I have taken as 1 atm. So you got this as 22.4 liters. Now we'll write the equation here as always. H2 plus half O2 gives you H2O. Fine. First we have to write the stoichiometric coefficient. Here 1, here half. They have given the values of two reagent. So what you have to do? You have to find out the limiting reagent. So first you have to find out the number of moles. They have given the weight. So number of moles of hydrogen given mass by molecular mass. Given mass of hydrogen is 4, molecular mass is 2, so number of moles is going to be 2. So it's oxygen, given mass is 32, molar mass is 32, number of moles is 1. So you got the number of moles of hydrogen 2, number of moles of oxygen 1. Number of moles with stoichiometric coefficient, if you divide, you can able to see that this will come as 2 and 1 by 1 by 2 this also comes as 2. So here we don't have any limiting reagent, both are consumed fully in this particular reaction. So now if you wanted to find out the amount of water formed, either you can equate with this one or this one. It doesn't matter which one you equate because we don't have any limiting reagent. Now I am going to equate with hydrogen, N of hydrogen by stoichiometric coefficient, N of water by stoichiometric coefficient. N of hydrogen by stoichiometric coefficient is 2. N of water and the stoichiometric coefficient of water is, we already know that it is 1. So it's going to be 1. So what is the number of moles of water? It's 2. And it is at STP they are asking what is the volume of water vapor formed. At STP you got 2 moles of water. 1 mole of water occupies a volume of 22.4. So the volume of water vapor is going to be 2 into 22.4. That is 44.8 liters. Right, you got the idea. So this is how we have to solve. Number of moles of water is 2. You already know that the equation number of moles is equal to volume by 22.4 at STP, right? So volume kandupidikam na, volume is equal to 22.4 into N. N we have found out here 2. 2 into 22.4, 44.8 liters is the answer. You can directly get the answer from here. Look at that. If you got 1 mole of hydrogen and a half mole of oxygen, you will be getting 1 mole of water. Now we got 2 moles of hydrogen, 1 mole of oxygen, then you are going to get 2 moles of water. If you get 2 moles of water, then the volume occupied by 2 moles of water is 44.8. Either way, both ways you can do. Better you stick on to one method so you will not be having confusion. That is what I am trying to explain you here. And look at this. Last question we'll discuss this one again, NTP. NTP or STP, that's okay, fine. So we are gonna talk about the NTP condition. In a container, 100 ml of nitrogen and 100 ml of hydrogen are mixed together. Find out the produced volume of ammonia. So in a container you are mixing nitrogen and hydrogen. So you should know the equation, they haven't mentioned that. So N2 plus 3H2 gives you 2NH3. This is the famous equation, classic equation, so you know this one. Stoichiometric coefficient I am writing here 1, here 3, here 2. What they have given? They have given the volume. Can we equate volume? Yes, given value by stoichiometric coefficient, the value can be volume too. So volume by stoichiometric coefficient you can use. So volume by stoichiometric coefficient if you use, nitrogen is going to be 100 by 1 and hydrogen is going to be 100 by 3. Right, given volume by stoichiometric coefficient. So from this we can able to find out which one is the limiting reagent. 100 by 1, 100. 100 by 3, that is going to be 33.33 something. So hydrogen is going to be our limiting reagent. Then find out the produced volume of ammonia. Produced volume of ammonia we have to find out. Equate hydrogen with ammonia. So how we will be equating? Volume by stoichiometric coefficient of hydrogen is equal to volume by stoichiometric coefficient of ammonia. So volume by stoichiometric coefficient of hydrogen, we already know that it is 100 by 3. So you got it as 100 by 3. And here volume of ammonia we have to find out. Stoichiometric coefficient of ammonia is 2. So what will be the volume of ammonia? Volume of ammonia is going to be 100 into 2, 200, 200 by 3. That might be 66.6666 something. So you got the ml volume of ammonia easily. Right. So what will happen if they have given weight? That is what the example we have done here. If they have given weight, you cannot go directly with the weight by stoichiometric coefficient. Weight we have to convert into number of moles. But if they have given volume, we can directly use the volume. You got the point? And this is how you have to solve the questions related to limiting reagent. I hope this is going to be easy for you to solve. Right. Thank you.